Hello students, welcome to the class of software engineering. Next topic we are going to see is types of application software. So when I talk about application softwares, what are they? So let us see the different types of application softwares. First one is standalone applications. So you can see here there are many application software. Let us discuss one by one. First one is standalone applications. What are these standalone applications? These are systems that run on a local computer such as your PC. They need not be connected to the internet. So now that is the main thing. So for example, if you have Microsoft Office, then to work on it, it's not necessary that your system should be connected to the internet. So just a local computer is enough for that. Second one is interactive transaction based applications. Interactive transaction based applications. So these are applications that run on a PC or I can tell terminals. So these include web applications such as your e-commerce applications, where you can interact with the remote system to buy the goods and services. So this example like your Amazon or Flipkart. So it should be connected to the internet, I agree. And mainly these are nothing but your web applications. So such as your e-commerce applications like your Amazon site or Flipkart site, where you will be actually interacting with a remote server there. Remote server you are interacting and making the transactions in order to purchase the goods or the services. Third one is embedded control systems. Embedded control systems. See, these are actually software control systems. They will be mainly controlling the hardware. Okay, so these are software control systems that will be controlling and managing your hardware devices. For example, so you have a mobile phone with you. Okay, so there are softwares in this one, isn't it? Softwares are designed in this mobile phone which are used to manage the hardware units. So there are also hardware units in this one. So those are managed and controlled by the software programs which have been designed. Another is software that controls anti-lock braking in your car. That also. Another thing is software in microwave oven. So you know that all of you have microwave oven which is used to cook your food, correct? But how exactly is the working? That is, everything is software control. It's the hardware, I agree, but everything is controlled by software. Okay. Fourth one is batch processing systems. What do you mean by batch processing systems? See, these are business systems that are designed to process the data in large batches. We will consider large batches and process the data. So they process large number of individual inputs to create the corresponding outputs. They process large number of individual inputs to create corresponding outputs, like your phone billing system you think. So how many people will be having this landline phones you think? So residents are more. So the data is more there. So how we are going to process that data in batches? Like if you consider one locality, who all are the residents having that landline phone? You will take that list and you will process the data and calculate the phone bill. You cannot take immediately. You cannot calculate for the entire city. You have to process in batches. Like that, even the salary also payment system. Okay, so if you take your college system, we have professors, associate professors, HODs. So all their salaries are not same. So based on the designation, you can process that data. So that's why it's helpful. Fifth one is entertainment systems. Entertainment systems. So these are systems which are used for personal use, just for enjoyment, to entertain the user, like certain gaming apps you have, no? Next, systems for modeling and simulation. This is for a larger thing. These are systems that are developed by scientists, mainly for the scientists and engineers. To model any physical process, they can use these systems. So, for that purpose, they require high performance parallel systems for execution. So, it's mainly for the research area. Seventh one is data collection system. Where is it? This is being used. Data collection system. See, these are systems which will collect the data from their environment. How it will collect the data? It is using a set of sensors. Okay, through the sensors, they are going to collect the data, get the information, send that data to other systems. Why? For processing. Send that data, they will send that data to other systems for processing, like your weather station data. Last one is systems of systems. So these are systems that are composed of a number of other software systems. These are systems that are composed of a number of other software systems. For example, a spreadsheet program. A spreadsheet program. Now we'll see the software engineering ethics. We have to see what are the professional and ethical responsibilities of a software engineer. So, what are the ethics a software engineer should follow in an IT industry? First one is confidentiality, second one, competence, third one, intellectual property rights, and fourth one is computer misuse. Let us see the first professional and ethical responsibility, that is confidentiality. A software engineer should respect the confidentiality of your employers or clients, irrespective of whether a formal confidentiality agreement has been signed. So, what does confidentiality tell us? You know that first the clients will approach the company people, or I can tell the customers, and they will put forward their proposal in making the project. So they will be specifying the requirements to the company, and the company has to design the product. So initially they will sign an agreement. That agreement says that they have chosen a contract between both of them in order to design a product. So everything this matter, whatever information is shared between the company and the client should not be exposed to the outside world. So this is the main responsibility, ethical and professional responsibility of software engineer should not disclose this matter. So should respect whatever the confidential agreement has been done, should respect that. Second one is competence. Should not misrepresent your level of competence. What is your skill? So you should not misrepresent your skill, or should not misrepresent your work, your talent. So you should not knowingly accept work that is outside your competence. Like suppose you are an employee of XYZ company, and at the same time you are working for another company. This should not happen. This should not happen. Third one is intellectual property rights. Intellectual property rights. So this thing is software engineer should be aware of all the local laws also governing the use of intellectual property such as patents and copyright, whatever. So he must be having idea of those things, patents, copyrights, so. So those are the nothing but the intellectual property rights. Fourth one is computer misuse. Computer misuse. So what does it mean? The software engineer should not use your technical skills to misuse other people's computers. So there are employees who will be using others' PCs for some other purpose. and the intention behind it might not be very good. They might be very talented, but still their intention might be bad. So computer misuse ranges from trivial, relatively trivial, like game playing on an employee's machine, to extremely serious virus. So leaving some virus into the system, hacking the system. All these things should not happen. So these are the professional and ethical responsibility of a software engineer. Now, here we are going to see the IEEE standard given. So earlier in general, we are talking about the professional and ethical responsibility of a software engineer. We have confidentiality, competence, intellectual property rights, and computer misuse. These 4 points. But again, the code of ethics for the software engineering is given by IEEE standard. So when it is asked IEEE standard, you need to explain these points. When it is asked about related to IEEE standard, then you have to write these points. So there are 8 points here. 8 principles are there. 8 principles are there. Keep in mind. First one, we'll begin with the first one, that is public. So public, you know what is the meaning of public. So it is to the people or the population of the country. So software engineers shall act consistently with the public interest. So whatever they are developing, no, it should be in favor of your public people only. So it should not cause any harm to public people after using that system. So it should benefit to them. You should benefit to them. So you should think in favor of them only. Okay. So whatever you are building, it should be in use to them, benefit to them, and it should not cause any harm to them. Second one is client and employer. So client, you know, is the customer who gives the task for you to build the project, and employer is who select which company you are working on. So software engineers shall act in a manner that is in the best interest of their client and employer, consistent with the public interest. So in parallel with this public interest also, they means the software engineer should also think always in the positive side only, always in the positive side, always benefit, always in the favor of their client and employer. Third one is product. Software engineers shall ensure that their products and related modifications meet the highest professional standards possible. So what do you mean by product? Finally, software engineers develop a product. So they have to uh, prove that their product, and if any modifications is done later to that product, will meet the highest professional standards. Okay. Fourth one is judgment. Judgment happens in the case of discussions. So, software engineers shall maintain integrity and independence in their professional judgment. So, whatever they say, okay, they should keep in mind what they have said, and they have to follow that one only. So, they have to not change it. Fifth one, management. So, managing a project. Software engineering managers and leaders. See, for managing the entire project, you'll be having a software manager, I can tell. Main. He is the main manager. Below him will be the team leader. So, below the team leader will be the different members who will be working on this project. So, shall subscribe to and promote an ethical approach to the management of software development and maintenance. So, should always promote an ethical approach in managing the entire project. Should do it very well. Sixth one, profession. What is their profession? They know, isn't it? So, software engineers shall advance the integrity and reputation of the profession consistent with the public interest. So, always respect their job. colleagues. Seventh one is colleagues. Profession you have understood. They have to always respect their job and they have to keep it in a reputed manner. Reputed manner. Next is the colleagues. Colleagues. Software engineers shall be fair to and supportive of their colleagues. All colleagues are there with them should always be very good to them, fair to them, and they have to support them in every stage. Eighth one is self. Self is yourself, correct? So what is that? Software engineers shall participate in lifelong learning. So you have to learn the things throughout your lifetime, I can tell. So as you know that new technologies emerge day by day, you have to be updated. It's not that your learning process has stopped. You have to update yourself also. You should be able to adapt to learn the new technologies emerging in the market. Clear? So these are the different software engineering code of ethics. That is the professional and ethical responsibility only given by IEEE Standard. Given by IEEE Standard. Now let us see the different case studies. Okay. First case study we are going to see is an embedded system. So you know what is an embedded system? It is a software controlled system. So this diagram will show the activity model of insulin pump system. What is your system name? Insulin pump system. By the term itself, you have an idea that it's related to the diabetes problem. So we have some hardware system here, and to control that hardware system, you have built the software. So that's why it's an embedded system. So now this blob, that is a filled circle, it indicates initial state. It indicates initial state, and which is the final state is this one. Can you see here? Filled circle inside another circle. So that is final state. Just explain about it, okay? The case study. An insulin pump is a medical system. Yeah, it's a medical system. This is being designed for people suffering from diabetes. So it's a medical system. So now see how a medical system is making contribution in software. So that's why I told the need for software engineering. Softwares are required in every sector of your industry. Either it can be IT industry or it can be medical industry. Okay, so every industry you require this softwares. So how see this is a medical system and how software is influencing this medical system. An insulin pump is a medical system that simulates the operation of the pancreas. See, you know, pancreas is one of the organ of your body, an internal organ. So we'll see that one. The software controlling this system is an embedded system. So actually this is set up as an hardware, but which is going to control is the software. So the software controlling the system. So that's why it's called an embedded system. Embedded system. So it mainly collects the information from a sensor. So we have a sensor in the system. So it will collect the information from that sensor and controls a pump. There is a pump. So that pump will actually deliver a controlled dose of insulin to the user. So it will deliver the controlled dose of insulin to user. Now just I'll give a brief introduction regarding this system. People who suffer from diabetes, they use this system. So who actually use this system? People who are suffering from diabetes. So I'll just tell about diabetes. It is a condition where the human pancreas, that is the organ, is unable to produce sufficient quantities of a hormone, and that hormone is nothing but insulin. It's a condition where the human pancreas is unable to produce sufficient amount of insulin. So actually insulin metabolizes glucose in the blood. So that's why it's very important, insulin. It metabolizes glucose, that is the sugar level in the blood. The treatment of diabetes involves, now if a patient is having diabetes problem, what is the treatment? Regular injections of yeah, regular injections of genetically engineered insulin. So this is the stage where the insulin means first initial stage they go with the medication with the tablets, and if it's not working then they are going for giving an injection of genetically engineered insulin. So they have to take injections. So how can they take that process we are going to see? Diabetes measure their blood sugar levels using an external meter. So you have seen the external meters, so external devices. So through that you can measure your blood sugar level. So and then you calculate the dose of insulin that they should inject. Isn't it? You have to calculate the dose of insulin, how much insulin needs to be injected. Problem with this treatment is that the level of insulin required does not just depend on the blood glucose level, it also depends on the time of the last insulin injection. So keep in mind that what is the problem here with this treatment is the level of insulin required just not only depends on the blood sugar level, but also it depends on the time of the last insulin injected. Okay. So this can lead to very low levels of blood glucose. Means if there is too much insulin, that is low level of blood glucose. If too much insulin. If the insulin is too low, too little insulin means very high level blood sugar level. Okay, clear? So this can lead to either low sugar level. Low sugar level means the amount of insulin produced is high, or it can lead to high sugar level means the amount of insulin produced is low. So which is dangerous actually? Low sugar level is more serious condition as it can result in temporary brain malfunctioning and ultimately unconsciousness and death also can happen. So in the long term, however, continual high levels of blood glucose can lead to eye damage, kidney damage and heart problems. These are the things it can lead. So these are the problems later. Now, software controlled insulin delivery system. We have built this one, software controlled insulin delivery system. Might work by using a microsensor embedded in the patient. So a microsensor is being embedded in the patient to measure some blood parameters that will be proportional to the sugar level. So we will look back into the diagram now. Now we'll come to the diagram. First you have blood sensor. So microsensor is embedded into the diabetes patient's body. Why? To take read the different blood parameter values. So here it is the analyze sensor reading. So from this microsensor, you are starting to analyze. You will take the readings of the various blood parameters. Then you will calculate the blood sugar level. What is the blood sugar level? Now, next you have to compute the insulin. Based on this sugar level, you have to compute how much amount of insulin dose needs to be given. How much amount of insulin dose needs to be given. That is important, isn't it? So here, this is then sent to the pump controller. This controller computes the sugar level and the amount of insulin that is needed. It then sends signals to a miniatured pump to deliver the insulin via a permanently attached needle. So you can see, I'll just tell, here you are computing the insulin dose, how much needs to be given to the patient. So now you have the dose, how much dose, that you are maintaining a record. Insulin log means it maintains a record, like this day how much insulin has been given. Okay, it maintains at what time it is given. All those details will be maintained. Now compute pump commands. So you are giving some built-in, it's software control system, no? So you have built in some pump commands. So through the pump commands, you can pump the data. What is the pumping the data is nothing but your insulin dose. So that is sent through the insulin pump, control insulin pump. Through this insulin pump, it is sent to the diabetes patients. So here, very important thing is this type of system is a safety critical system. Very, very important. Safety critical system, because see, the system is of high reliability, I can tell. Now I'll use the word term reliability. High reliability you need to see compared to other systems. Since it is a medical system, it should not cause any damage to the user. Like suppose if the pump fails to operate or does not operate correctly, if it fails to operate, or suppose it doesn't give proper amount of insulin, then the user's health may be damaged. So that's why it's called safety critical system. You need to consider the safety issues here, or they may fall into a coma because their blood sugar levels are too high or too low. So mainly here, there are two essential high-level requirements that this system must meet. So this is very, very important. You need to mention here the two essential high-level requirements. So we are considering the requirements that also high-level and essential requirements that this system must meet. What is that? First one is the system shall be available to deliver insulin when required. So first requirement is your system, this medical system, should be able to deliver the insulin whenever required. Second thing is it should provide correct amount of insulin. The system shall perform reliably, that's why reliable, it is more reliable, and deliver the correct amount of insulin according to the blood sugar level. Let us move on to the next case study, that is a patient information system for mental health care. A patient information system for mental health care. We are trying to build a software system, that is patient information system for mental health care. So this is actually the diagram which I can tell it shows the structure of your system. So this mainly shows the structure of the system. So let me just tell about the basics here. Why this system has been built? What is the purpose of this system? So here, a patient information system to support mental health care is a medical information system. This is also a medical information system which will maintain information about patients suffering from mental health problems. Okay, and also it maintains information regarding the treatments that they have received. So most mental health patients, they do not require dedicated hospital treatment, isn't it? Yeah, but like your regular patients, they do not require dedicated hospital treatment, but they need to attend specialist clinics regularly, isn't it? So where they can meet a doctor who has detailed knowledge of their problems. So to check them, how much they have improved or not, or is there any issue or not. The nature of mental health problems is such that patients are often disorganized. So because they are suffering from mental health problems. So they are main thing I can tell is their mind is disorganized. Reason thing is they might miss appointments. Okay, there are chances that they might miss the appointments given by the doctor deliberately, or accidentally they might lose the prescriptions also, because you cannot predict the mentality of their mind. So they might lose the prescriptions and medication, and they may also forget the instructions how to take it up. So to make it easier for patients to attend, these clinics are not just run in hospitals, they may also be held in local medical practices or community centers. So they might, what they have done is they have built the system to run it in local medical practices or community centers. You can run it in local practical medical practices or community centers. So they need not go to the hospitals and take up the treatment. So you can see here now we have MHC-PMS. What does it mean? Mental Health Care Patient Management System. Okay, the full form is Mental Health Care Patient Management System. So keep in mind, because this case study we might be using in several modules, several chapters. So that's one. So here it is written local. What is that? Local machine. Yeah. Here also one local machine. Here local machine. All these are connected to MHC-PMS server. It's connected to one of the server. And the server in turn is connected to the patient database. It's a database which stores the details of the patient. So how it works? So the MHC-PMS is an information system that is intended for use in clinics. So it makes use of a centralized database of patient information, but has also been designed to run on a PC. So any local machine you can use this system. Okay, so that it may be accessed and used from sites that do not have secure network connectivity. So that is one of the advantage you can use on your local machine. Now, who are the users of this system? Let me see who is using this system. One is the clinical staff. When I tell about clinical staff, it might be doctors, nurses, and health visitors. Health visitors are again nurses who actually visit people at home to check the treatment. So they actually visit the patients at home and check their treatment. Now other users are the non-medical users. We'll categorize them into non-medical users, like the receptionist who will be making the appointments, receptionist, and another one is the medical record staff. Medical record staff, what do? They maintain the record system, entire record system. And we also have administrative staff. Their job is to generate the reports. So see, keep in mind these many are the users of the system. One is the medical users, another one is the non-medical users. So there can be receptionist who can make the appointment, medical record staff who maintain the record system, entire record system, and administrative staff is to generate the reports. The system is used to record information about patients. So main thing is in the database the patient information is stored. So what all information it can be? Personal information like name, address, age, all. Then even the consultations. When was the last consultation made, date, which doctor was seen, subject to impression of the patient, what impression or remark has been given by the doctor, what is the condition also will be specified, and what treatments have been done. So these are the things. Next we'll come back to the diagram only. I'll explain this organization of your MHC-PMS system. What are the key features of this system? Key features we'll look into of this system. First one is individual care management. Individual care management, how it is? Clinicians can create records for patients. They can edit the information in the system. So they can, first thing is they can create, that is either the doctor's they can create the records for the patients, they can edit any information, they can view the patient history, all those things they can do. So individual care management, so they will get to know easily about the patient. The system supports data summaries so that doctors who have not previously met a patient can quickly learn about the key problems and treatments that have been prescribed. So here the thing is, suppose if the doctor is new in that clinic and he doesn't know, he has not seen the patient till now. So he can, from the database, he can get the summary report of the patient. So he can get to know all the information regarding the patient. What is his name, what is his problem, what treatments he had taken till now, all those. So there is individual care here. Third one is patient monitoring. So this system will help the doctors or the nurses to regularly monitor the records of the patients, okay, that are involved in treatment. So can monitor the patient regularly and issues warnings if possible problems are detected. So if any kind of problem is there, then a warning message is also being sent. Like for example, the appointment has been made and still the patient has not met the doctor, not seen the doctor, then a warning message may be issued for him to remind about it. Third one is administrative reporting. So this is related to the reports generated. So this system will actually generate monthly reports, monthly management reports. So it will show how many patients have been treated at the clinic and how many patients have entered and left the system, and what all treatments have been done, and what drugs has been given, and what is the cost, etc. All those details will be generated. So that is about the MHC-PMS system. Now, so this is actually the organization of that system. So you can see that all these local machines will be connected to the server, and server in turn is connected to the database which stores all the details of the patient. One more case study we'll look onto is a wilderness weather station. A wilderness weather station. So this is just a structure or organization. A wilderness weather station. So you this type of notation, keep in mind, this type of notation represents a subsystem. So we have one is weather station, another one is data management and archiving, and one more is station maintenance. So we will go into depth of this topic. See, to help monitor climate change and to improve the accuracy of weather forecast in remote areas, the government of a country with large areas of wilderness, okay, have decided to deploy several hundred weather stations in remote areas. So in order to monitor the climate change and also to improve the accuracy of weather forecast in wilderness areas, the government deployed several hundred weather stations in such remote areas. So these weather stations, what they do? So several hundred weather stations have been deployed. Several weather stations have been deployed. So these weather stations collect data from a set of instruments that will measure the temperature, pressure, rainfall, sunshine, wind speed, wind direction, etc. All those. So we'll see the systems. First one is weather station system. You can see here you have weather station system. The weather station system, this is responsible for collecting the weather data. So it is responsible for collecting the weather data and also carrying out some initial data processing. So this weather station is responsible for collecting all the weather data, and it can start with some data processing and transmitting it to the data management system. So that data should be sent to which one? Data management system. So what does the data management and archiving system do? Now, this system collects the data from all of the wilderness weather stations. So, you know that hundreds of stations have been deployed in wilderness area means this data management system will collect all those data from all those weather stations deployed. Then it will start the data processing. So, it will analyze the data. Okay, analyze the data and it will process the data and archive the data in a form that can be retrieved by other systems. So archiving, so you are archiving the data in a form so that it can be retrieved by other systems such as weather forecasting system. Weather forecasting system is mainly used to forecast the weather conditions. Third one is the station maintenance system. So we have here in the figure station maintenance system. So what does this do? This system can communicate by satellite. Through satellite, it can communicate with the weather stations. Okay, station maintenance system can communicate with all those weather stations in the wilderness areas by satellite. Why? To monitor, to keep track of the health of these stations. If there are any problems, you need to report it. So it can update the embedded software in these systems. It can do that one. Clear? So these are the three key features, three systems I can tell in a wilderness weather station. Okay. One is weather station, which is responsible for collecting the data and sending the data to data management system. So here it can collect all the data from all different weather stations and it can start processing, and it can archive the data in a format that can be retrieved by other stations such as your weather forecast systems. And then you have the station maintenance system, which is actually going to communicate with your weather stations. Here you can see how the line is being drawn. With the weather stations, it can communicate through satellite in order to monitor the health of these stations. Okay. So we have seen mainly the three case studies in this session. The first one is the insulin pump system. Second one is the MHC-PMS system. And third one is the weather station system. So these are the different case studies we have learned in this video session. Thank you.